Okay, so hello everyone. Thank you all for being here. So welcome to the first What Should Gen3 Be workshop. Hopefully there will be many more in the upcoming conferences. My name is Mohammed Hassoun. I'm from King Fahd University of Petroleum and Minerals in Saudi Arabia. And along with Professor Greg Durgan from Georgia Tech, we are we're organizing this workshop. So the way this workshop is going to be conducted is like we are having four excellent experts in the field of RFID. So we're having Dr. Chris Diario from, please excuse me if I butcher your name. I'm notorious for that. So we have Dr. Chris Diario from, he's the CEO and co-founder of MBing, one of the leading companies in the field of RFID. We have Dr. Brian Degnan. He's with the White River Technologies. And we're having Professor Stuart Thomas, and he's with Bucknell University. And the fourth speaker is, I don't want to say the last speaker, but I will say fourth speaker. So the fourth speaker is Dr. Rahul Bhattacharya. Am I pronouncing your name correctly?
You're doing fine.
Very close. Okay. He's with MIT Auto ID Labs. So first of all, I would like to thank the four speakers for their time. And the way this workshop is going to be conducted is we're going to hear from each one of our speakers. They will have probably like 5 to 10 minutes. They can go likely more than 10 minutes. And all of them will going to share their ideas and opinions, ideas, and envisions about the future of RFID. So for speakers, after finishing with the speakers, the floor will be open for a Q&A. So if you have any question, please type it in the chat, and I will echo your question to the speakers. So let me start with Chris. I know he doesn't like the question, what should Gen3 be? So let me rephrase the question and say that what limits the adoption of RAIN RFID? So Chris, the floor is yours.
Okay, thank you, Mohammed. And I was actually going to talk about the three things in, Gen3, three things in particularly in RAIN RFID that I think could have an enormous impact on the future. And so I don't have slides. I'm just going to say a few words. And I'm going to start by saying that RAIN RFID, and by that we mean RFID based on the UHF Gen2 / ISO 18000-63 protocol. But RAIN RFID has really made enormous strides since we as an industry ratified the Gen2 protocol in late 2004. Seems like ages ago, and in some ways it is a long time ago, right? I mean, it's been more than 15 years. But as I always tell people, any fundamentally transformative technology takes time. And what we as an industry are doing is connecting every item on the planet, extending the reach of the internet by a factor of 1,000 to everything. And that cannot happen overnight. It is not possible to happen overnight. We're in a multi-decade technology evolution that is fundamentally going to transform how people engage with everyday items. So last year, the industry delivered 18.5 billion endpoint ICs among use cases spanning retail, supply chain and logistics, automotive, aviation, healthcare, and even NASA is using RAIN RFID to track products to go on spaceflight. The technology, we might say, is mature. It's mature enough for those use cases, but I'm actually going to make the point here that we're just beginning. The technology really is not that mature, and we have so many unsolved problems in front of us that are, in many ways, very exciting and very fun. The AIR protocol today, the Gen2 AIR protocol, is probably, in my view, the most robust part of our industry. We can engage in reliable communications at 1,000 items per second at a 10-meter range and get good readability of those items and get the unique identity of each individual item, and going forward, we'll get its authenticity as well. Even going beyond that, get its location. So the Gen 2 protocol can be made better. We know that. We all know that. But it's pretty good today. And even today, the modifications we did to the Gen 2 protocol, which we ratified Gen 2 V2 in 2013, they remain mostly untapped. In that protocol are capabilities for authentication, item authentication, cryptographic security, loss prevention, files, a whole bunch of capabilities that mostly from an industry perspective remain untapped. So there's a lot more breathing room in the Gen 2 protocol as it stands. So it's not that we can't improve Gen 2. And I know the academic industry has a key role in pioneering those improvements. But I'm going to say that we have so many other less well-developed and higher impact areas to explore that those areas are what I want to focus on here. So in the theme of Gen 3, which is the title of this, this session, I'm going to talk about 3 things that I think the industry can focus on that are high impact and will have an enormous, could change our industry enormously going forward. And they really focus on RAIN RFID, but they somewhat extend to all types of RFID. So they are, the first one of my Gen 3, range and location. Today, a reader can inventory an item. We've got basically a short-range radar system where the tag backscatters its reply. Conveniently, the backscatter reply contains information about the item, but all we can say is the item is present. It's kind of a radar system that looks out in the environment and says, I see something. You can't tell where it is. No systems in the field today provide an accurate range to an item or really accurate location. And there are no less than 18 papers in this conference that touch on location. Yet, from an industry perspective, really, I mean, Impinj has our X-ray. There's other products out there that purport to give some crude locationing, or they say it's fine locationing. And it is, we can get to within a meter accuracy given enough reads of an item. But compared to what is possible from a technology perspective, we as an industry can do much better. And to the extent that we can get fine-grained location in a single read, when you get the identity of the item, you can know where it is and the distance to it, we can much better solve problems out in the field. So I'm going to say that range and location have enormous potential for the future. We've made progress already as an industry across multiple years, but we've taken one step down a path for which there are many steps. The next one that I'm going to say in my number 2 in my Gen 3 is tag clutter. So many applications today can't read the tags they want to read. I'll use as an example vehicle tolling. Vehicle's coming along, doing 100 kilometers an hour down the highway, is going to go to a tolling station. Tolling reader turns on, or it's on all the time. There's a tag on the windshield, and somebody just bought 30 items in a Zara store and they're sitting in the back seat. The reader that's sending the queries, they generally don't send select commands to select on tolling tags because there's not enough time to select the tolling to send the select command. And even if you send the select command, it's not clear that the tag is going to hear it. Can't send a select command when the reader tries to inventory either the license plate tag or the windshield tag, the example that I used. The reader is much more likely to get the items that are sitting inside the car. And so tolling applications and other applications, any application that needs to read quickly when there are clutter, and I'm using the word clutter here just to mean unwanted tags. They're not bad tags. There's nothing wrong with them. They just happen to be not the tags that the reader needs to read. That clutter problem stymies applications. Stymies, in some cases, tolling, makes race timing, marathon timing more difficult, makes loss prevention use cases more difficult. I want to read the tag leaving the store, not all the ones inside the store. It makes many transition use cases difficult. That problem also remains open today. That one is probably the most easily solved of all the problems because the solution really here is finding a way to discriminate the tag you want to read. But today, we as an industry have not yet settled on a solution. So that's problem number 2. That is a high impact problem, high impact solution. Number 3 is both the hardest one. Number 3 of my Gen 3 is both the hardest one and the most interesting, and it's number resolution. What do I mean by that? If you think today, there are multiple numbering systems out in the field. There's the GS1 numbering system, EPC. There's an ISO numbering system. There are all kinds of proprietary numbering systems. In fact, there's a multiplicity of proprietary numbering systems. I'm going to call them all proprietary because none of them are effectively cross-resolvable. For example, you take a pharma tag into Delta Airlines, they can't figure out what it is. You take a Delta Airline tags in a pharma application, they can't figure out what it is. And to an individual person like you or me, for whom we want to extend the internet to the Internet of Things, we can't resolve any of them. If you want to try it, take a handheld reader out into the field, wherever you want, and read a tag. See what you get. You get a bunch of hex characters. Stick that into any browser, anything, any way you want, and you cannot get information about the individual item. Delta can get information about your bag, for example, because they have the backend database, but it's not exposed to you. And you may say, well, I don't need to know the Delta database. All I need to know is they track my bags. And that's true for Delta. But if I go into a store and want to buy an item, or if I have a tag on my bike and it gets stolen and I want the police recover it, I want that number resolvable to me. I want my bike back. So to an individual person, every system appears proprietary, and it's impossible for us to get information about an item or resolve the item to a digital twin of that item in the cloud. And we as an industry are not going to make inroads with people using RAIN RFID until we can give those people the benefit of tagged items. We're not going to get our readers into phones unless the phone, by reading something, the person can get information. It's relatively easy to put a reader inside a phone. It's harder for the person to get information about that individual item. So my number 3 and hardest but most exciting question to the community is, how do we create an open Internet of Things despite the fact that semi-proprietary numbering systems are proliferating essentially unstoppably? There's more and more and more of them. The answer has to be that we need to treat each number as a random. Whether it's an EPC numbering system, a GS1 number system, or a proprietary one, forget decoding it, doesn't matter. Treat it as a random. Treat it as a pointer through an IPv6 address to a location in the cloud where you pull the information about the item. Forget whether the number is even decodable or not. Forget if it's EPC, whatever, it's a random. Go to the cloud and get the EPC from the cloud and get all the information about the item. How do I treat that number as a pointer? And how do we build a distributed resolver that's democratized, distributed, not centralized? It has to be distributed in the current world we live in. A distributed resolver, and if it's distributed, how do we keep that resolver, or that if you want to think of it as a lookup table, there's an index of entries from item to cloud, how do we keep it coherent? The coherency is actually the hardest part of the problem. The number of entries in that table, even for 10 trillion items, is not that large. You have to solve the birthday problem with colliding numbering systems, but you can solve the birthday problem in the future by just checking out numbers. If it's already taken, you don't get that number. The question is one of how do we get people to start doing it, and how do we keep multiple copies of a distributed resolver coherent? That's an especially fun problem and hugely relevant. And to the extent we as an industry can solve it, we will enable people to connect with items. So to me, Gen3 RAIN RFID is more about solving the unsolved high-impact problems, which are range and location, tag clutter, and number resolution. Every one of those is a big, meaty, and fun problem. That's not to say we shouldn't keep working on how to improve the air interface. Keep doing that, guys and gals. But even more than that, let's see where we can even make a higher impact. So that's my intro.
Thank you very much, Chris. I see like one question actually for you, but we'll keep it till we're done. So next speaker. Sorry.
No, go ahead. Keep going. Sorry.
So next speaker will be Brian Degnan. Brian, can I ask you what should Gen3 be?
Well, so I have had the privilege of looking at RFID tagging from the unique standpoint of I did not have pricing pressure, which is something that almost never happens in any industry. And Chris actually really hit one of the interesting things I always harp on. And so when I was looking at, I agree with Chris about kind of the state of some of the problems. And these are some of the problems I was looking at. Specifically, I was looking at the authentication and problems, and how do you deal with a tag that is in an untrusted environment? And what does this mean? So first, I just want to speak to the birthday party problem. And this was kind of the big one that I was harping on in my kind of teaser. So if you read the Gen2 v2 spec, it says that for, I believe, 100th, I'm going to get this wrong, but for 10,000 tags, there's only to be a 1% chance that 2 of them have generated the same random number. Sadly, that is not how probabilistic mathematics work. So if I have a 16-bit random number, there's a 50% chance that 2 tags have the same number as 600 tags. And then it goes on from there and asymptotically approaches 100% probability once you get to about, I think at 900 tags, it's like a 99% chance. So the one kind of low-hanging fruit as far as the spec, because the over-air spec is rather robust, having some way to have basically a larger random number space. And this is important on 2 sides, but I'm going to also talk about how the industry has to change how they do it. So the random number is fine, actually, because if you look at the data, often people in the query command where it actually specifies how many bits for your slot counters to use, I found most people actually don't use very many of them, and they basically use time. I cannot actually speak to Impinj's implementation, but I have some others. But you see this actually reading through a lot of these papers where you can kind of get a feel for it. They're like, yeah, it worked great till we got about 100 tags and it started falling apart. Often, I believe that things started falling apart very likely because of how they're handling the random numbers and the collisions. And because the collisions is actually a big thing no one talks about. Because if you think about it, it really is just a signal processing problem. If you want to throw an infinite amount of computing power at it and get some really nice network equipment, there's no reason we can't have 1,000 tags reflect back at us, and we can't like pick out all the whole numbers. But that's a pricing problem. So the big things for me, looking forward to improvements, would be authentication for cryptography and a slightly larger random bit field. And I believe this is kind of the time for this. So when you write a specification, you're writing it for a minimally viable CMOS implementation. Usually if you reach down and kind of dig down to see what choices are and you think back, it's like, so Gen 1 was 2004. If you read that, it reads like a 2004 spec. I see 130 nanometer there. I can get some feel for what's going on. And then if you read the Gen 2 V2, the changes, you're like, yeah, that's 2013. You kind of get a feel for where the pricing would be. So the other side to that is I think industry is going to have to take a big lead on this. And I know they're going to be reluctant to kind of say things like this because they're big into the adoption of it. But if you're like, so what is an economically, like what amount of authentication and cryptography and all those other things, like how much on that little piece of sand is economically viable? And that's a good question that no one has answered. And once we know that, we actually can start having the discussions how to extend this, maybe Gen 2V 2.5, just to get some of these things. It'd be nice to have and are wanted by certain niche industries, but just haven't really been pushed down yet into the worlds of, the Lululemons of the world and the Walmarts. Because, and one final thing, there's always going to be a little bit of a disconnect between what I'm going to call the cryptographers and the mathematicians and kind of the academic side who are looking at pushing these out into the field and acceptance. Because if you're sitting here and you're looking at AES, I'm looking at all the circuits and everything it takes for me to have my elliptic curve encryption and do my key exchanges and everything else, basically it takes billions and billions and billions of years to crack those keys. But if I have a $10 T-shirt, the pragmatist should say, well, you only need $10.01 of cryptographic strength to guarantee that, it becomes an economics game, to guarantee that's a real T-shirt and that's authentic. So there has to be some balance, and there's really, sadly, no one-size-fits-all for this. But I feel that there might eventually converge on like 1 or 2, 3 different groupings of value, and then that will then have an effect on the economics of the tags. And it's kind of an exciting time because it seems like every 7 years or so there is an update. Like you had Gen 1, you had 7 years in Gen 2. So maybe it is time for Gen 3, but maybe it's not. So that's all I have there.
So I'm going to interrupt for just a second, Mohammed. So Brian, just one note. The reason that we put the crypto suite indicator and did not choose a cryptographic suite in Gen 2 V2 was exactly the reason you cited. Because there's different use cases, different value spaces, and there was no one-size-fits-all crypto suite. And even if we had picked one and something had happened with it, it wouldn't have worked going forward. We would have been screwed. So we basically said, let's put a CSI in there and have companies basically have all the crypto suite. So we're going to do the crypto on the other end up in the cloud. You're going to get you're going to get a response from the tag. You're going to figure it out in the cloud. We can have as many crypto suites as we want. It doesn't matter.
Yeah. The thing that's kind of interesting though is one of the challenges I have been working with is the cloud. And when you have the specification, you cannot guarantee connection. You really lose a lot of this flexibility. Because in the cloud model, so we're going to generate a random number. It's going to come down from the cloud where the keys are shared. So we're going to go send that random number in plain text across to the tag. The tag is then going to encrypt with the key. We come back with our encrypted number, and we're compared to the cloud. And that's really powerful. But there's ways to make things self-signed. Other that might be interesting only because getting everyone to agree, as you said before, Chris, getting everyone to agree on something, because I totally see your number problem. Like, I have been dealing with that. It is a disaster. And I wish there was a single database in the cloud, but getting people to play together, this doesn't seem like something that's going to happen on this playground, at least in the next few years, until there's a pain. And it might actually be, the one interesting thing about cryptography is, if there's enough of an industry driver to include this on tags, you suddenly do need this database. And it gives you enough of a pain that everyone might actually play together, just when you come to the point of if you have enough pricing pressure for things like anti-counterfeiting, and authentication of your tags. Because that's also, as an example, is the whole authentication scheme solves the clutter problem as well, because you could always split your tags between the ones that are like your RFID reader going by where it's really quick, and ones where you want to make sure it's actually what you think it is, but it's just a dollars and cents game.
Thank you very much, Brian, and thank you very much, Chris, for pointing out the reason for that, for not including more bits in the encryption of the tag. So the next speaker will be Stuart. And Stuart, again, I'm going to ask you this question: what should Gen3 be?
Thank you, Mohammed. Thank you, everyone, for coming to this, and for thank Greg as also Paul, Greg Durgan, in organizing this. I'm excited to be a part of this. I think it's interesting to talk about this. Chris, I loved what you said. I like your 3 points for Gen 3. So that was great. I think that's some good things to talk about. So my perspective is going to be a little bit different, because I can sit here isolated in my ivory tower of academia, and I am a little bit disconnected from industry, and I don't have to worry about, I don't think about adoption rates. I think about where's the research going on and what can we do. And even in most of my research involving RFID, very little to none has actually been on the Gen 2 or the RAIN protocol. I've been looking at what we can do with backscatter more broadly. So my perspective just inherently is a little bit different with that. So my apologies when I step on industry toes if anything I talk about. But it's been really fun this week. We started out our very first session. We had the folks at GS1 and come and talk about some of the history of the protocol development, why it was developed, and what people were trying to do, where it's going. And I thought that was really great. I think one of the big takeaways was, if you don't have a business case, then you don't really have or need a protocol at all. So I think that was, for me, that's also just something important to keep in mind. So what is the business case for what we are trying to do? And the other thing, when we think about the history of RFID, I mean, ID is in that name. It's inherently tied to identifying something. And the history was trying to replace a barcode. And we have done a very good job at that. There's still many problems, like the Walmart pallet problem. I still don't think we can ID 900 things in a pallet. That's kind of what both Brian and Chris have been talking about for many reasons. So yeah, I think that's something big to solve. And we ID things better, faster, more precisely. My perspective, though, is if we look at some of the research that's been going on, and even I think of some of the keynotes I've really talked about that even this week, is that I'm going to give my 3 problems. But what we have kind of right now, my first one is that we have a reckoning, it seems, of what do we want the future of RFID to be? Where do we want to go? Where do we see ourselves? I don't necessarily see that we're going to replace Gen2. I think that is a very tried, battle-hardened protocol, and it does its job well. I think we can improve on it. But I'm also thinking, where else do we want to go? Where's the research pushing at? And I think even there's a question about that. But what we can really see is that we're integrating more and more sensors into RFID, and we're wanting to now interrogate those more often, get more data coming back. And so what we're really coming up with is a data problem. And that's what I see. We have the backscatter link, and we've really been doing a lot of research. Some of my early research was looking at quadrature amplitude modulations and packing multiple bits per symbol, and that can make more spectral efficiency. We can now get more data on that, and it opens up some interesting tricks you can do. It also kind of shows that the backscatter link, there really is not any difference compared to a traditional transceiver. We just have to kind of get our circuitry better, and that flips kind of the way we think about that. We have not looked at the downlink much, the reader to tag link. That's really, we're still just doing the good old envelope ASK modulation. But other than that, what we have is a normal RF link. A lot of the work in the University of Washington has been showing a backscattering tag that can talk Bluetooth. And so that is something that opens up a lot more opportunities to interface with other systems. So kind of what y'all are saying, and can we work with other systems? Can I run my Ethernet over RFID RAIN tag and now communicate with other networks? That I think would be cool. But so my first is, what do we want to be? What do we want to be? Where are we going? What do we want to look like? Do we want just still a predominantly IDE protocol? Do we want to do a more general IoT high data rate protocol that makes use of low power backscattering? And so I think that would allow us to increase the data, looking at higher order modulation. There's several papers kind of looking at that now, several groups. And then the other thing, what I really think this brings up, the major limiting factor that we have is there's a power issue. If we want more range, get more power. I mean, that's easy. Turn up the RF link. That's going to do it. We want our tags to last longer. Well, harvest better. Just get more power. And I think what I would really, really love to see happen, and this is me just sky high. This is beyond what I think could be in a protocol. But if we can have a dedicated wireless power transfer frequency, just say FCC, give us 10 hertz. I don't know, give just whatever narrowband they can do that we're not going to interfere. Probably more than 10 hertz. But give us something that we can do. We can beam power on, and now we can have dedicated RF channels to harvest power that we're not going to interfere, that we don't scatter on. We're just getting energy, and I think that would open up a lot more use cases for what we can do. Sensing, improving the data rate. I think the last keynote just talked about that most DACs and sensors we use get like 1 mega samples per second, and RFID right now, I think state-of-the-art was 300 samples per second, trying to use a RAIN interrogation protocol. So that's kind of where I see. I really, instead that we're at least talking about this, we're seeing like, what do we want the future to be? What could it look like? What do we need to work on? So I am looking forward to continuing this discussion, starting it now and continuing in the next couple of conference series. So thank you.
Thank you very much, Stuart. The next speaker will be Rahul, and I believe all you have some slides, isn't it? Or are you gonna? You have to unmute yourself.
Talk through them. What's up?
There you go.
Okay.
Okay. Can you hear me now? Okay.
Yes.
Yeah, I do have some slides, but I think they're short enough that I can just talk through them as well. So for me, actually, I'm really happy, Mohammed, that you put me last, because I think I can sort of just jump off some of the talking points that both Chris, Stuart, and even Brian said in their conversations. And the way I like to think about Gen3 is more about how to position RFID as a core backbone technology for IoT. So especially what we've seen in the past, I would say at least 5 to 10 years, is that there have been more and more wireless protocols that have been coming in that sort of, people use, like LoRa, Bluetooth, Zigbee, RFID, all these different types of things, all of which basically are there to sort of bridge the physical and digital divide. RFID works great as a wireless ID, but I think with some of the peripheral technologies that go beyond just core RFID, you can dramatically enhance the versatility and capabilities of RFID to help bridge that physical digital divide. So for example, I'm going to be talking about, I'm just going to sort of leave 4 examples. There are advances in additive manufacturing, smart materials, machine learning, computer vision. We've seen much more of those, at least in the last 5 to 6 years, even in our conference, in terms of how they've sort of been enhancing the range and the capabilities of RFID. So for example, now you can 3D print antenna arrays on surfaces that are not just flat, but actually might be curvilinear. So now suddenly, if you want to put this on a stealth fighter or something like that, it's much more capable, easy to do that. We've seen things like perovskites, which are solar cells that are now bendable. So you can start putting them inside things like golf balls, dramatically enhancing the range as well as providing additional power that can be scavenged to do things like sensing. And we've seen people sort of even manipulating the environment in which a tag is supposed to be deployed, so that you can do things like communication and sensing. For example, I read a paper recently where these folks are converting the super absorption polymer inside a diaper to sort of double up as an antenna. So the idea is that if an infant or an adult diaper gets saturated with urine, it basically forms an antenna and then kind of broadcasts the fact that it's wet over at least a 1 meter range. And so, there's a lot of creativity that sort of you can do by going a little bit multidisciplinary. And that's sort of like the point that I wanted to make. So I wanted to sort of just leave two open questions here, just because we're sort of brainstorming, where Gen 3 could go. So one problem that I really see is that as RFID really scales, you start having millions or even trillions of tags. What are you going to do with these tags when they reach the end of life? Do they end up in a landfill? There's quite a lot of innovation that's been going up in organic conductive materials or in plastic-based things that are conductive. I would love to see sort of environmentally benign RFID tags. Perhaps they can be recycled much more easily with other kinds of plastics, or maybe they degrade over time. That might be something that might be really interesting. And sort of coming to the numbering systems that Chris was talking about just recently. Personally, a lot of work that I have done has been in analog RF sensing. So the idea here is you're not really adding any electronics or sensors in the chip, but you're sort of encoding sensing information into the signal response of the tag. So the amplitude, the frequency, or the phase. Do you need like a numbering standard for that? So right now I get an EPC. I look at some sort of signal parameter associated with that EPC and I know, okay, the temperature crossed a certain threshold. But if, let's say, I want to know that that's a temperature tag, do I need to have some sort of a numbering standard for that? That's something that, we may want to think about, especially if, these really dirt cheap analog based sensing starts becoming much more pervasively available. And sort of that led me to two other things in terms of scalability. So right now you can get around 1,000 reads per second, but let's say now you have a box that, like, let's say a box of produce that not only has an ID, but it also has a bunch of other like EPCs that also give you sensing information. Now all of a sudden, one box has got 10 IDs that are doing something or the other associated with them. Is that going to create some scalability problems in the future? That's something that might be something that I was thinking as well. And finally, data privacy and accessibility. Right now, people talk about, okay, if I don't want someone to read my RFID tag, I just wrap it in aluminum foil and it's shielded. But if you do have sort of like a sensing thing associated with the ID, suddenly it could really raise much more privacy issues. For example, let's say I'm sitting in a staff meeting, I turn on my RFID reader and I can just read a bunch of IDs, that's okay. But what if I read one incontinent diaper tag and I know that somebody or one of my peers basically has an incontinence problem? That suddenly again raises a lot more privacy issues as well. So, that's just two things that I kind of wanted to go into. And I guess the rest we can address by question and answers in the panel. Thank you, Mohammed.
Thank you, Rahul, and many thanks to all of the four speakers. So now it's time to Q&A, and let me start with the first question in the chat from Brian Degnan. I don't know who this person is. So he was addressing this question to Chris, Brian, saying how much of this innovation on ranging constrained by cost. Do you believe that the application the application user just doesn't see the ROI that would be required by the slightly more expensive hardware.
So that's a difficult question to answer quickly. I will do my best. First, I'm going to say that the elasticity of demand in RAIN RFID is huge. If you look at the METI announcement in Japan 2 years ago, where they said if you can get down to an identifier cost of roughly a penny and a half, they said they said a yen, a little bit more. If you get down to a cost of a penny and a half for embedding a digital identifier in an item, it becomes cost effective to tag every item in a Japanese convenience store. And the average item in a Japanese convenience store costs $1. Essentially, that data point, which has been replicated in other studies, if we can get down to an incremental cost of a penny and a half for a digital identifier, a wireless identifier, we can tag every item on the planet. We can tag every lemon. So cost is a critically important component. But then I'll also say that cost is not really our fundamental problem. And I'm going to get at it this way. Number one is that our industry as a whole is still in relatively immature silicon technologies that were state of the art in the year 2000 or the state of the art a couple years after that. As we migrate down Moore's law, cost of the digital on the chip asymptotes to zero. So the cost of a crypto engine or some of the other things you're talking about over time becomes asymptotically small. So to Brian's question, what does it take to put a crypto engine on a chip? Put it on a chip. As we go down Moore's law, the incremental cost is going to be relatively low. And the fact that you have a key on the chip at that point, combined with the number on the chip, means that if you've got a 128-bit key and a 128-bit number, you got 256 bits, your birthday problem essentially goes away. It's the key, the number to key binding that essentially gives you your space uniqueness. So then I'm going to answer one more part of the question. And maybe this isn't the clearest answer, but I'm doing my best here. Think of our industry as being reliant on 3 bindings. The first binding is the item to the number. Let's call the number an EPC. The second binding is the EPC to the number of the IC. Let's call that the TID. And the third binding is the TID to key binding. Only one of those bindings and 2 of those numbers needs to be on the tag. The TID needs to be on the tag because it identifies the IC. The key needs to be on the tag for anti-counterfeiting. Everything else not only can be someplace else, but should be someplace else. In fact, if you want to make anti-counterfeiting robust, you put the minimum number of bindings on the tag. If you include the EPC, if you include the item with the EPC and the TID on a tag, you've given a bad guy 2 of the 3 bindings. All the bad guy has to do is break the TID to key, and he's got the last binding. You take the EPC off the tag and stick it in the cloud, you save memory, you saved cost, and you've made the system more secure and robust against counterfeiting. So the answer is for us to make, I believe, the minimal tag that accomplishes the minimal binding, which is the TID to key binding, and locate everything else off chip where, in the cloud, the cost of memory is 1/1,000,000th that of the cost on a tag. For every bit in a tag, I could put a megabit in the cloud for the same cost. We drive down the cost by leveraging the cloud. And if we get the linkage between item and cloud, we can actually enhance security, basically, prevent counterfeiting, get a lower cost IC, and a better performing system that is more reliable and robust because I can step on a tag and break it. I can't step on the cloud. So going forward, as we think of more and more connectivity, the value proposition is put the minimum stuff on the IC. I'm not telling you anything, take off sensors and all those other kinds of things. Just put the minimum on, drive the cost down, enhance the capabilities of our overall system. So I know that was kind of a long-winded, kind of meandering answer, but it's my best way to get at it. Cost is critically important, but I think we can get there even with the things we want to do. And I'm kind of minimizing the cost of a crypto engine because digital goes to zero.
Well, yeah, digital does go to zero, assuming, being on 14 nanometer, whereas a bleeding edge, there's going to be blood. The analog just, has always been a challenge. And this is one of the other things is like, I always hear this. And Gordon Moore wrote a paper, put 4 plots on it. Carver Mead called it Moore's Law. And we've all kind of rolled with it, right? And this is very true. I completely agree with you. So then this is another dynamic is it comes down to is arguably, do you really want to get things down to a yen? Maybe the answer is a little bit more elegant from the standpoint of it's just an analog problem. I mean, the specification, perhaps they should have been, the chip should be, the Gen 3 should actually be designed around, okay, let's have a minimally viable just code, like Chris said, and then figure out what an analog front end would look like that could support that. That's generally not how things are designed. Maybe in this case, that's how it should be designed.
All you need is the key and the TID on the tag. Fundamentally, that's all you need. And you want some more information. You need to say who made the chip so that you can actually figure out how to use the TID and the key to actually authenticate the thing. And you really want to have who made the inlay as well, so that you actually have some calibration information over the air interface. But the rest of the stuff is, it just, you need 2 numbers on that chip. But Brian, to your particular point there about analog, I have a PhD project for somebody who was any student who wants to take it up. And I think as of where we stand right now in the industry, this is solvable. What is the fundamental limit, if any, on the sensitivity of a RAIN IC, or pick any frequency you want, sensitivity IC? How much power can we extract from a radio wave? And you can take away the size of the antenna. That's just a parameter in the thing. Is there a limit on how much energy we can extract from the thing? There clearly is, because there's only a certain amount of energy is available. You can get to 100% efficiency. So to say it the other way, is there a limit on the efficiency of the AFE in one of these tags for extracting energy, and what is it? And nobody knows. I'm going to tell you right now. Well, I certainly don't know. I've never seen anybody who says they know. The efficiency of front ends right now is still relatively low compared to the amount of power coming in. What is the power harvesting efficiency of a rectifier, and what is the fundamental limit on it? Outside the normal limit, which is I can only absorb 100% of the energy on the antenna, but that's not the answer. That would be a fun research project, and it remains an unsolved question. Once we know the answer to that, then we can start answering questions about how much power we have. Then we can understand what we can do on the analog side, and I'm going to tell you the digital side is don't care.
Thank you very much, Chris. Another question for you, actually, comes from Jonathan Gregory, and he was asking, how can tag clutter, that's topic 2 you addressed, be addressed if you have a license plate tag number resolution, which is the third topic that you addressed.
How can we solve the clutter problem?
If you have...
Yeah, so we don't solve the clutter problem by making the air link faster, because if you make, it's sort of like increasing the width of a freeway. You make the freeway wider and just more cars come on it. So we actually need to solve the clutter problem by pre-selecting which tags we want to have respond. If you have to take the tolling example, what I really want to have happen is to have only the toll tag respond, and the toll tag only know that it's the only tag that's supposed to respond, and the other tags not want to respond. There is there's an application identification working group getting started up in the RAIN Alliance to investigate this problem. And the answer needs to be having some sort of an application identifier such that the reader can communicate with the tag and say, for this application, I only want, or for this response, I only want toll tags to respond. But actually, it will be some more general class. But how you create that class structure, that application ID structure, how you make it ubiquitous, and how you get everybody to adopt it and reinforce it is an unknown question right now. So this is much more of a standardization issue. You could say, well, just use the AFI, the application family identifier. The AFI was never really constructed with that thought in mind. We could potentially co-opt it, but it's not ideal. The question is, how do you instruct? How do you partition the tags into classes, and in the command that goes over the air, a query command, instruct only tags of that class to respond? That is an eminently solvable problem with good industry alignment, and I'm optimistic that that industry alignment will come from the RAIN Alliance, and we would incredibly welcome academic support in that effort as well. And there's a way for even if you're not a member of the RAIN Alliance, well, for academic institutions to join the RAIN Alliance, it's easy, and we have provisions for outside experts to come in as well.
Thank you, Chris. There is another question from Raphael. He's asking, probably to all of you, does Gen 3 might focus on the integration of RFID reader into smartphone chipset? And let me start with Stuart. What do you think?
Sure, I can speak to that. I think the question is why isn't every phone an RFID reader? And I think probably the biggest reason is that we like phones small and fit in our pockets, and we need a very large battery to be able to get the power. It goes back to power. So you have to send a vast amount of power out over the air, over the RF link, out to the tag to power it up and respond. And that takes quite a bit of energy. I think maybe starting to look at like active RFID or some sort of semi-passive means. Can we start looking at that? Would that be able to work? And I think that might be more feasible. But as it stands now, trying to power up a passive UHF RFID tag is that would be a very heavy phone with a very bulky batteries. I guess that would be my perspective on it. What stops us from that? Looking ahead might be again more power for the tags to have is what I'll go back to. I don't know. What do you all think?
Nice. Brian?
I'm happy to. Or Brian, go ahead. Or others?
Oh, no.
But I'm talking too much. I'll let others go first. But I have an opinion on this one.
It's a signal problem fundamentally, you know, and so that takes a lot of computational power. I mean, one of the things about having spent a lot of time in Japan, and the Kavini is a near and dear place to my heart. I understand the idea of like tagging everything, but also it's kind of a use case. When I think of my phone, right, and I have my Japanese cell phone, I'm going to use the NFC reader to pay for me to go through the subway. I can't imagine myself, like, quite honestly, paying with a sandwich in the same way. And I think it's going to be the use case. If there was a real driver where we needed this, I'm sure somebody would come up with maybe a very short range, like we're talking about tens of centimeters, way to address it. But I'm going to say that although there's probably no real reason you couldn't do this on the centimeters range, there's just probably not an economic driver.
Okay, I'll pipe in here without trying to talk too much. So I've done actually a little bit of investigation into this question. If you think of the use case, think of two use cases. Number one use case, you're a consumer and you're going into some location, you want to get information about an item. Let's say you're in a store, you want to get information about a particular item you're thinking about buying, not about the class of item, but about the particular item. That's a use case. Another use case is you are walking through an environment, let's say a store again, because stores are easy. There's other use cases here, but use case you're walking through a store, and the store is actually going to use you as a reader to crowdsource the identity of items in their stores. You leave your phone on, you walk through a store, you crowdsource the location of items in their stores. That's actually a valid use case as well. There are others, but if I just think of those two use cases, the read speed you need is 3 tags per second, which means the duty cycle you need to operate at is 1%. And the amount of power you need to transmit, well, what's the gain of the antenna? Well, it turns out we operate at 900 megahertz in RAIN RFID, so you can diplex into the phone main antenna. So you don't even need to add an antenna. You got to pay the insertion loss of the diplexer, which hurts a little bit. The phone guys get a little bit upset about that, but you can get over that. So you can actually put the reader into the phone if you assume you don't need more than a meter of range. You don't need to read more than 2 or 3 tags per second. The main problem is that from a phone manufacturer's perspective, you want to put something into a phone that consumers want. But to the point I made before, if I put a reader in a phone, and by the way, I have a phone with a reader in it. It's got a little bit thicker battery. There's some you can buy. I bought one. You go into a store, you can't get any information. You can read all the tags you want anywhere you want, and all you get is hex characters. And so there's no value proposition for the consumer to buy a phone with a reader in it. If there's no value proposition for the consumer, the other use cases I've talked about are essentially irrelevant. Because if I'm not going to pay for the phone with a reader in it just so I can crowdsource the location of items in the store for the benefit of the store, it doesn't give me any benefit. So once we solve that number resolution problem, then we go to the phone guys and say, look, people can get information about items. And then we will literally have behind us the retailers and others saying, I want my consumers to have readers in my phones. And to that point, if Decathlon made a presentation at one of the RAIN Alliance meetings and put up a wish list of things they wanted, a wish list of 5 things. And one of them was readers in phones. And they're willing to talk to, and they said they're willing to talk to phone manufacturers and say, we as Decathlon want readers and phones so our consumers can read our items. So there is a use case there. The answer is nobody can resolve the numbers. Solve the number problem. There'll actually be a consumer use case. With a consumer use case, we can solve it. Diplex into the phone main antenna, operate at a 1% duty cycle.
Thank you, Chris. Rahul, what do you think? Do you think
Yeah, I mean, I think I would have gone with Brian and Stuart's answer. My main thing would have been the power. And then, Brian alluded to the fact that NFC is in the phone already. So, I was like, yeah, it's a range power thing. But then it's a fascinating perspective that Chris brought that I didn't even think of, which is, yeah, you could certainly do a lot with crowdsourcing. So I think, yeah, what you said, Chris, makes a lot of sense. I have nothing more to say.
Thank you. Thank you very much, Rahul. The next question from Edwin Can. This question is addressed to both Chris and Brian, and he was saying, Gen 2 is designed for logistics of item level ID. When more sensors, say temperature or 6 degree of freedom, can be integrated to the UHF RFID, the tags data field needs to be read continuously. Pulling every time may not be efficient, and Gen 3 include RFID-based sensor considerations.
Brian?
I guess. So, one of the things about Gen 2 is it's not really designed to be continuously read. Like you power up a tag, and then basically it's going to have its session. It's going to then be done with it. It's going to stay on for 2 seconds. That's kind of how the spec reads. You could possibly change this if you had one tag and you turn off your carrier wave and it would crash, go back. And you could retrofit a Gen 2 V2 tag to use the user space memory and do a memory map there and say, okay, here's your sensor data, and you can read it out. But the thing that hurts you if you want this constant streaming is just going to be that you're kind of stuck with just a handful of tags, at least with this spec. And I'm generally not sure the best way to address it. So, for instance, there's a paper with these CubeSats, and they're using RFID in space for a temperature sensor. That's a great example of just like a point out there in space with some sensor. And I want to just finish with, because sensors have always been challenging, right? Because as soon as you have one sensor, someone wants 20 sensors. These specifications usually don't scale well. So I think there's a place for it. I just don't know what it would look like. But it definitely is that continuous sensing, is going to be hard with Gen 2 V2.
Mohammed, you're on mute.
Chris, what do you think?
I agree with everything that Brian said. I will say that the Gen 2 protocol essentially assumes a stateless tag that does not have a reliable power source. And the idea is that the tag has to be able to power down at any point in time, which tags do all the time. Just a slight bit of movement, they can get in a multipath balance or something, lose power and come back up later. And they don't retain their state when they power down. They can't retain their state. We don't have the right NVM. We don't have the right capability to retain state. So the whole Gen 2 premise of the Gen 2 protocol is you essentially have a tag that powers up it powers up, reestablishes. It doesn't reestablish communications. It just communicates. And when it loses power, it loses all of its state and comes up again, essentially and afresh. And with basically a power harvesting device that can power down at any time, trying to maintain continuous communications requires the tag to maintain state. You don't have any way to do that. And I can't envision a very good way to do that. Any kind of storage capacitor will eventually run out, and you can't do the NVM because you don't have enough power to do the write. So it's very difficult for me to envision a passive backscatter device doing continuous streaming. If you have a battery, great. And backscatter communications, just the point Stuart made before, backscatter communications is incredibly powerful as a communications paradigm because I don't need the cost of a transmitter, cost being in power domain. I don't need the power of a transmitter on this low power device. And so the backscatter communications is incredibly powerful. But if I want to have continuous communications, I need power on the tag. And the Gen 2 protocol is simply not set up to do that.
Thank you, Chris. George and Rahul, do you want to add something to it? Okay, very good. So the next question is from Pavel Nikitin. He's asking about, it would be interesting to hear the opinions of the pros and cons of various form factor tags. Simple tags, simple, flexible, passive LAs versus smart tags, battery assisted and PCB. So this question is addressed to all of you who want to go ahead and start. So let me start with Rahul.
So just so that I'm understanding the question, if you have different size form factor tags, so as compared to smart tags, so like, I guess maybe I need a little bit more clarification about the question. Like, are you asking, like, does it make sense to have a smaller tag in some situations, which is probably less powerful than something that is like a standard sensing platform? Is that the question? I guess I maybe just need a little bit more context.
Yeah, I think let me try to restate the question. So the question is like about, I mean, restating the question with the current like trend in backscatter communication RFID. Would it make sense to like change the form factor, go for like different form factors tags, or move to the battery assisted tags, or just stay with the current passive tags?
I think that's in my opinion, there's no silver bullet solution, because the application space is just so diverse, right? In some cases, for example, if you're trying to tag tools that you're using in an oil rig, for example, and you just want to collect them in a smart receptacle at the end of the day, you probably don't need a lot of read range. But what you do need is something really tiny that you can fit into a socket or something like that. So in that case, I think having something passive, which is small size, makes a lot more sense than something that has all the bells and whistles of a battery assisted thing. On the other hand, if, like, I don't know, you're trying to instrument your subway tunnels with, gas detection sensors that can communicate the fact that there's a noxious leak over much larger distances, probably you do want to have something that has, battery assisted and range and is, maximally tuned and things like that. So I think it would be a case by case thing, in my opinion.
Chris, what do you think?
I'm going to give both somewhat of a predictive as well as a pushback answer. I think 10 years from now, there will be no tags. The IC needs to be an integral part of the item, manufactured with the item. The idea of an additive tag is a transition point in time. And the IC literally will be built into the item as a part of the item, whether it happens to be in thread that goes into fabric, or whether it happens to be in an encapsulated plastic thing or something that goes on difficult to read items, or whether it's built into the cardboard of a box, or whether it's part of a label that goes on food products or part of the poly bag, or whether it's actually part of a paper, of a potato chip bag. That's the metallized mylar. And there's a little tiny slit in the metallization, but not on the mylar. And there's a little strap that goes across it and uses the bag as an antenna. My prediction, 10 years from now, we will have no tags. The IC will be an integral part of the item.
Thank you, Chris.
I just want to add something to that a little bit. I think Chris is raising a really important point about when we think about if we're talking about a new protocol or something new, we could have ICs that now live in things like structural health monitoring, buildings, just clothes. We're going to have devices, or not devices now, just things, objects with an extremely long digital lifetime, because those ICs If it's buried in like my kid's teddy bear, and that's scary. Don't think that's an idea. But there you go. That weird, whatever that is. So we have ICs now buried in these that we're not going to touch. We need something that can last a long time. We need a protocol that can last. I think the GS1 example started discussing HTML, but what is something that we are still going to be able to use 10 years from now?
And it won't have a battery, right? Stuart, if it's going to last 10 years, it doesn't have a battery, which is the whole benefit of Gen 2, no battery.
Mm-hmm.
This is Songoku. I don't know what you call him in English. He's part of the Going West. And this is I got this at RFID last year from a Chinese company who basically makes anti-counterfeit things for toys. And he has a AES encrypted chip somewhere in the middle of his head. I've tried to figure out where it is without cutting it him apart. But yeah. So I think Chris is right, because like that removes a couple things. And what I was always looking at is, when I was doing my research, people were mostly concerned about changing things post-manufacturing. But if it's integrated in there, you can do a lot to make sure that it doesn't have to. You decrease the risk of somebody like retagging it. You decrease the risk. I mean, you could rip off his head and find it, yes, but you can't sell it.
Thank you, Brian. Stuart, I have a question actually related to this topic. When it comes, especially when you talk about like increasing the modulation, do you think it's valuable now to move to battery-assisted tags?
I think it depends on the use case entirely. One of the big advantages and what really draws me just academically being interested in RFID is the fact that it's battery free and it's an extremely low power way to transfer data. And I think that just is such a neat idea. And then now you can start, I like to think, but you can start now doing sensing of different things, objects, whatever, without needing to go change battery. So I think there's a great deal of value and utility in not having a battery. I just, in some of my perspective, I think looking at some of the research is that people are just wanting to not have to change a whole lot and just think of, we have an RFID or a RAIN or Gen3, whatever we want to call it, but just some sort of backscattering front end that we can just glue on to an existing system. And now we can automatically get way more power efficiencies for our device to send data. And I think there's also a lot of value in that. So I am interested in a protocol that would allow for both fully passive operation, but also battery assisted without having to do anything. Gen 2, of course, allows for that now, but something more. So it might be that the reader starts out yelling very loudly with a high carry wave, much like, I'm going to annoy all of you at home right now, much like when your Alexa is screaming, you say, turn the volume down, turn the volume down, turn the volume down. Then you negotiate a power level or an audio level that works. That might be the solution. But I think something that in operates both battery assisted as well as passive is important. But I do see value in this as some sort of protocol for high data rate backscattering systems that we can just glue on to existing IoT devices. Now all of a sudden they get these IoT devices or whatever sensing systems get the benefit that RFID tags have of low power communication.
Mohammed, can I ask a question there just for a follow up with Stuart? Is it just a real quick follow up? A RAIN tag doesn't have a 900 megahertz oscillator on it. We don't have the power for it. So we don't have a coherent system. So essentially, the front end of the tag is an envelope detector, and the tag doesn't know anything about frequency, the RF frequency. Is there a way to do a QAM, quadrature modulation, in that environment that is actually workable for a receiver to be able to detect and a tag to actually modulate, yet the tag not having knowledge of the RF frequency? Is there an efficient way to do that?
So I have looked briefly at this. That's my plan to look at that later. Anyone wants to help me with this. But in short, I think for a very narrowband carrier, yes, it looks like there are ways to get lumped elements, and you can kind of delay the signal and get a 90-degree delayed version as well as the original version. But then you're bound to a very particular frequency. And then it would be possible to start doing things like FM demodulation. You might be able to do QAM demodulation. But I think a bigger question is, can you make a frequency agnostic detector for those signals? And that I don't want to say it's impossible. I have no idea how it would work, and that would be a big open question. If that gets solved, then I mean the door is wide open for what we can do.
But even if you just think of the backscatter link, is there a way to do that? And if there is a way to do it, how do you resolve initial state? The tag's got to start up with an initial state, like a phase state for capacitor, but the phase state for the capacitor would inherently be mismatched because you got to go to the other state, and so you detune the coupling to the antenna, so you lose power. So I've thought about it a little bit. I've never been able to figure out the right way to, or if there is a way to actually do other than just what we end up doing, which is essentially on-off keying or ASK modulation. We don't actually do any phase modulation because it's hard. But if you could actually do phase modulation on top of the amplitude modulation, then you could do something. It would be like a QPSK, but without knowing the RF, it seems hard to do. So that was the genesis of my question.
Yeah, I took a look one time just from a circuit perspective on the front end about. So one of the cool things about RFID tags is the same thing that makes this hard. They work from 860 megahertz to 960 megahertz, and in the world of designing analog circuits, that is a huge range. I feel that there might be a really kind of niche solution for like North America or China, but getting both of them, it's just the realities of fab. I could probably design something that would sort of work, but then when I made it, by the time everything's off by 10%, it would be a very expensive piece of thing.
Just do it for 902 to 928, because with the EU2 band is now in the 900 megahertz range, and Japan has come down to the 900 megahertz range. So if we were ever to do a Gen 3, one of the things I would want to do would be just to constrain at 900 to 930 megahertz, and at some point get rid of that 860. Now we need the 860 EU band for an extended period of time going forward for legacy reasons, and because not all countries have adopted the new EU2 band. But at some point, it will actually turn out to be easier to build systems that don't use that old EU1 band at 860, and it'll eventually get deprecated. That's probably a decade away, but I can foresee that in the future, because building narrowband systems, it's not really narrowband 30 megahertz at a 900. It's not classified as narrowband, but it's way easier than 100 megahertz. That'd
be great. The efficiency of your charge pumps could go way up. You could design very specifically around these frequencies. I mean, I think that would open up a lot of really nice applications because, low capacitive load, you could start doing QAM and everything else. I think that's a great point, because anything that makes, because the analog is the baddie. Anything that makes the analog easier gives more options for everything else.
Thank you.
So back to that PhD thesis question. What's our limit in sensitivity? Anyway, sorry, Mohammed. Keep going.
No. Thank you very much. So there's a question from Shankem. He's asking Rahul. Rahul mentioned the privacy. He was asking how much does the effect of privacy laws play into the development of Gen 3 protocol?
Well, that's a good question. I mean, I think it's an open one. I mean, given that we are still trying to struggle with, how much should Facebook know about you? I think awareness is a good starting point. So you kind of just make everyone aware of the fact that, okay, if you're planning to use this technology, particularly if you're planning to use this in the context of sensing, where you might be sensing something private or sensitive, this is what somebody can get on you. That would be a great starting point. So people can choose whether to opt in or opt out. But then beyond that, I think whatever we do to solve the privacy issues with other kinds of things, mobile, could probably port that here.
Thank you, Rahul. Brian, you were about to say something, right? Okay.
I can jump in here. I'll say one thing.
Yeah, please. Yeah,
I always have
feel free to jump in anytime.
That's
really good.
On the privacy question, I have just two thoughts. Number one, what I want to do is push as much of the privacy question off the chip into the cloud as we possibly can. Again, storing the minimum data on the chip so that we can leverage standard protocols, standard security, standard everything in the cloud, and store as much of the data as we can off the chip. To me, that's step number one. And then step number 2, once you've pushed as much data off the chip as you can, I believe the chip problem becomes a binary one. Either it's responding or not responding. And so Impinj introduced what we call protected mode in our most recent M700 product. And not to tout the product here, but just basically said we introduced protected mode. And what it does is it allows a consumer or the owner of the item to make the tag invisible with a pin. So either the tag's responsive or it's not responsive. And if they hide it with a pin, the tag won't respond to anybody unless it receives the pin first. So that idea of having a pin to turn the tag on or off, and only the owner of the tag knows the pin, actually gives you a binary solution to what the tag can reveal. And then to as much as possible, take whatever else is on the tag, put it in the cloud, so that you don't have to go to the tag to get information about the item. You go to the cloud to get information about the item. And so that's our thought from our company perspective about the solution. And I'm guardedly optimistic that that approach will prove to be viable for the long term.
Thank you, Chris. So there's another question to Chris from Professor Durgan. He's asking about number resolution. His question is the next big tech company the one that sells digital twins with the linkability that you mentioned, viewing RFID tags, reader, cloud storage, etc., as included costs?
I don't know the answer to that question. If I had my choice, what I would love to see would be a fully democratized, open number resolution that's not tied to any company, because we're talking about connecting every item on the planet. And any company, or first, I don't think any company is big enough to do that, even though it's not many numbers, but to basically manage the space in any one company or any one entity or any one country or any one government that pioneered the solution and said it's mine would put every other country or company against them. I believe that the solution needs to be a democratized, distributed solution. We need a distributed resolver. And after that, where the data gets stored, I don't know about you guys, but for me personally as Chris, I want my data stored on my server in my home. I'm my own cloud. My tag points to my server in my cloud. I don't care what other company offers, it goes to me. And if I happen to be a company selling items, I might choose to use Microsoft Azure or AWS, or I might decide to do it myself. I want my ability to put my data where I want it. And as long as there's a resolver that's democratized and decentralized that can connect my item to my cloud location, I think the world is good.
Thank you, Chris. A question to Rahul from Huli. He's asking about the way to make tags more eco-friendly by especially those which are nearing the end of their lifetime. So what are the ideas as how to effectively recycle these? How cost efficient and feasible would it be to be able to retrieve these tags and recycle them?
Yeah, so I think the answer would be is to design the tags using the material that you're planning on recycling. So this comes from a project that we did recently where we kind of had chipless RFID tags on different types of plastics, so type 1 to type 6 plastics. We did the project using your standard aluminum printed tags, but we were recently talking to some folks who actually were able to functionalize part of the plastic, turning it conductive. And so imagine so in that case, when you are recycling something, you don't have to go through that added step of extracting that tag and then figuring out what to do with the metal. The tag could just crumple or be disposed based on the in situ material itself. So I think thinking about how you could functionalize the environment or of the material itself in a way that it can sort of reflect energy in a meaningful way probably is the way of the future, and how you can create something that's eco-friendly, recyclable, and doesn't add too many steps for extraction, thus making it much more likely that it will be actually recycled and not just tossed into a landfill. So that's my thought.
Thank you, Rahul. Thank you, Rahul. The next question from Alan, and I believe the question is addressed to all of you. So feel free to jump. So the question is like, is it more industry or academia that's driving the need for Gen 3 protocol?
Academia. Like academics like stuff. We like to play with stuff. We like to break stuff, right? I mean, of the people here, the only person who really is advisory opinion about actually the real world is Chris, right? Because he's the guy selling the stuff. I mean, the majority of most academics' careers can be described as, that was cool, we did this, presented it, summarily dismissed, moved on to the next thing to be summarily dismissed, right? So generally, these things are, academic is like throwing up a bunch of balls, and you look at these papers, you see what cool ideas came up with, and one of them will be caught by somebody. It'll actually be good enough to be considered. But if you are looking at this from the business perspective, Gen 2 V2 is fine, right? It's all about adoption, and and this is what Chris said, like, what's driving adoption? How does it look in the future? He's looking at these very pragmatic problems. I mean, I look at making something slightly better. Stuart looks at making the protocols slightly more efficient. Raul looks at making it so we don't just kill each other with landfills. So I would have to say it's academia who cares most about this.
Thank you.
I was going to jump in and say, yes, there is an assumption that there is a need for a Gen 3. I don't know if we've adequately addressed that or not. I just go back. It depends on what we want to do. If our goal is to just identify objects wirelessly, Gen 2 V2 is really good at that. I would just say that in the research in the past decade has all been really pushing on using the backscatter link to do way more stuff. And that gets in like what Chris said, range localization, but just we want to be able to do more cryptography and more. That means we need more bits per second. We want to get more sense data. So I think there's a need for some more generalized IoT-ish backscatter-based protocol. Call it what you want. And I would say that academia and the research community is definitely driving that. I don't know if there's much an industry business need.
Chris, what do you think?
I agree with what Brian and Stuart said. What the industry wants right now more than anything else is adoption, stability, and adoption. It's stability that drives adoption. Changing the protocol right now, there's some desires to make some minor enhancements around the edges, but you need something that's 100% backwards compatible and doesn't look scary to any of your end customers. Because look at where we are. The industry delivered 20 billion roughly ICs last year, 18.5, but call it 20. What's the total number of taggable items per year? Roughly. Think of all pharmaceutical items, all retail items, all blood draws, all biospecimens, all food items, all automotive items. Rough it out, 10 trillion per year. So we're at 0.2%. So what industry wants to do is get from 0.2% to 10%, and we get that by having stability and solving the problems that are actually impeding adoption. That said, to Stuart's point, I do think that there's incredible power in using backscatter communications broadly outside of RAIN, outside of RFID entirely, because taking the transmitter off the low power device means your power consumption goes way down. Unfortunately, you've got this your air link basically, you've got the link budget problem based on the fact that the backscatter communications is backscattering on the same link, and so you've got a R-squared problem in each direction. So you're never going to get the kind of range with a backscatter system as you would with a fully coherent radio system with a transmitter on both ends. But in many applications, it doesn't matter. So applying backscatter communications to all the things we're seeing it being applied to, Bluetooth and Wi-Fi and every other domain, I think is actually a powerful area of research. It's probably even more powerful than trying to drastically improve the Gen 2 protocol, because there's not that much incentive to drastically improve the Gen 2 protocol.
Thank you, Chris. Rahul, what do you think? Academia or industry?
No, I think I agree with what Brian and Stuart says. I mean, I think that academia sort of can work on things that are cool and interesting. They may be 5 to 10 years ahead, but then some of those ideas do percolate down. Yeah, I don't have anything more to say.
Thank you, Rahul. There's a question to Chris from Zachary Thompson. How would you go about trying to find the limiting bar? The question you pose for your PhD student. That seems very interesting. That's his way.
How would I go about trying to find it? So, so you can make, I can't answer the question because that's a job for the student. But I would look at it this way. As you start decreasing the voltage available to a chip, any front-end device that you're going to be using, CMOS or whatever device, is going to be operating in its exponential regime, subthreshold in the case of a MOS transistor. So you're looking to maximize the input voltage to the IC. So what do you do to maximize the input voltage while retaining bandwidth? And then how much efficiency can you get out of a rectifier under those conditions? And you want to try and drive the peak rectifier efficiency through the exponential front end of the device into what is effectively, in all inlays made today, a transformer on the front end. It's a one-turn transformer, but it transforms the dipole impedance through a coupling ratio to the IC. So how do you maximize the voltage at the input of the IC, and how do you do it with some bandwidth? And then what's the most efficient rectifier that you can build? And what are the fundamental limits there? And how do they manifest? And so I don't know the answer to the question, but I would start with recognizing that whatever front end you have is going to be an exponential front end, and you want to try and generate, and it's a voltage to current device on the front end. It's a transistor. How do I maximize the voltage on the front end? That's where I would start.
Thank you, Chris. The next question also for Chris from Weeson, saying, since we are living in the wireless sea, will we commercialize the passive tags which can harvest from Wi-Fi LTE signals so we can remove the dedicated radar?
So the question is, can we build tags that harvest energy from multiple sources? Is that the question? From multiple wireless sources?
Yes.
The answer is yes, but kind of in a funny way. Tags today have no idea what the RF is coming in. All they see is RF because it's a diode detector front end. So they have no idea if the signal is a rain signal, if it's a Wi-Fi signal, whatever it is, whatever's coming in, they're going to harvest. The answer is we do it today. Now, we don't design for it today. We don't really effectively design to harvest from a Wi-Fi signal. But if a Wi-Fi signal happens to be there and there's RF energy in it and it's CW long enough, yeah, we'll harvest energy from it. It turns out that one of the things we do in RAIN RFID is on the reader side we transmit a watt, and that's a lot of power. I mean, think of what we do, right? We use 1 watt to close a 10-meter link. I mean, anytime I tell people that, they're like, "What are you doing? You're using 1 watt to close a 10-meter link? That's nutty." Right? All the other radios transmit at much lower power than 1 watt to close a 10-meter link. For a watt, they could do kilometers, right? So their power transmissions tend to be lower, and as a consequence, there's not that much energy for the tag to extract. But it is the case today that if the energy level from one of those transmitters is high enough, the tag will extract energy from it. It doesn't know that it's a Wi-Fi signal. It has no idea.
Thank you very much, Chris. And if any of the speakers want, because it's almost 4:30, so if any of the speakers want to say a final word, please go ahead, Stuart.
Sure. So this has been good. I think I'm sure a lot of you on the audience have even more questions. So I'd be happy to get some more of those. But yeah, I think it's exciting for me to start thinking about this and talking about that. I think the RFID community. So I think we have all just been going all directions with the research for a while. So I think it's very fun to try to gather everyone around some common goal. And I think starting by saying what should Gen 3 be, what do we want, is a good way to do that. I think I've got a lot of takeaways there. I think kind of the perspective has been like more from a global view, like a big picture view of the number apocalypse or the number recognition. We need, I think, kind of my takeaway is that we need essentially the democratized DNS version for RAIN tags, whatever that is. So that's just a bigger view of RFID. I would like to see more data, and I think seeing what Brian has been saying about cryptography and Rahul with just systems thinking of if we're going to have tags everywhere, how do we recycle those? But it's been fun to look at that. Yeah, I guess that would be my takeaway. I'd be happy to talk more about my ideas for modulation and how that might work. And I think this might imply that it should not be called Gen3. It should be called something else, Thunder. I don't know, just to say it's not quite rain. But yeah, I think this has been good, and thank you all for letting me join the panel.
Thank you, sir. Thank you for your valuable input. So, Brian, what do you think? Do you have final takeaway?
I think that as long as there are academics, we're going to find something that's interesting for us to work on. And one of the things is I think we need to, and one of the valuable things about that I got out of this conference is usually is co-located with the trade show. So I get to walk around the floor and listen to people complain about what's broken. And that's good, because I was like, oh, that's what I'm working on is almost never really a problem, but it's kind of insightful. And whatever future specifications there are, I think there definitely needs to be people who are forward thinking, like a Chris Diorio, who really has his thumb on the pulse of the needs, right? And to just like that, everyone is kind of in on the conversation, right? Because certain things is I love his vision for a tag with just nothing on it. That's beautiful. That's very different from what I have been funded to make in the past by very bright people who have deep pockets. So there's obviously a lot of room here to come to a consensus, and I think we just have to keep talking. And the next few years will be interesting. We'll kind of converge on something, and then hopefully we'll have this panel again in another 7 years, and we can do our woulda, coulda, shouldas. But
thank you, Brian. Rahul, what's your takeaway from this?
So my takeaway from this is I think it's kind of interesting to start asking these questions now. I really liked hearing from my other panelists, as well as Chris, who brought the industry perspective that's sitting in academia. We don't often get as much. But what I really like particularly is the fact that there's just such a large diversity of problems that are being solved by the community, and the community just seems to be growing and it's getting more interdisciplinary. To me, that seems, given that we're like IoT is just such a complex problem, right? We talked about things like, how do you protect data? How do you recycle stuff? Then the general RF stuff as well. I just kind of feel that, I'd like to see the community grow, and like you said, we should revisit this in 5 years, because I think we're sort of at this like growth point where it's like, here's IoT, here's RFID. We got to figure out how to get these two worlds to kind of connect together a little bit better. And so I think having conversations like this more often definitely going to be interesting to see in the conference. So thank you for having me.
Thank you very much, all. Chris, what's your takeaway?
So first, I want to thank you, Mohammed, everybody, all my colleagues here on the panel, and Greg as well for hosting the conference, and also the people who asked all the questions. It's been really a pleasure to be here. I guess I want to close by saying a few words to those in the audience who are the students. You think back 20 years ago, the concept of the Internet of Things was popularized around was then RFID. We didn't even have Gen2 to connect everything. And the first use case was for tagging lipstick with a passive battery-assisted tag. The word IoT now has become to mean the Internet of Powered Electronic Devices, this tiny slice of what's connectable. I don't know how that became IoT. It was already there. I mean, this minuscule vision of the IoT is not the IoT. And yet that's what I hear about IoT is RFID is something separate. No, we are the IoT. We're going to connect everything on the planet. And it's the biggest opportunity there has ever been. We're going to extend the reach of the internet by a factor of 1,000. And there's tons of fun problems, as some of the questions in the audience and the answers that you guys all brought up. And so to the students out there, I would like to say, listen to some of the things that came up today. Look at what we're trying to accomplish. Get excited, because there's huge academic study areas here, whether it happens to be the analog circuits, the crypto, the digital, the air protocol, the numbering, the effective DNS, a distributed DNS, the clutter problem, ranging and locationing. We have just a wealth of beautiful problems in front of us. And there are great opportunities here to do research.
Thank you very much, Chris. I would like to thank you all for your time. Thank you very much for being part of this amazing discussion. I really appreciate your time. I would like to thank Professor Durgan for co-organizing this workshop. Actually, he's the man behind the scene. I'm just the face here. So I apologize for those who asked questions and we did not have time for them. So again, we're sorry. So thank you all very much, and hopefully we'll see you in a future workshop on Gen3. Thank you very much.
Is this the official close of the conference?